What's going on, everyone, and welcome to the first of hopefully many episodes of Math with Mr. G. If you're watching this video, chances are you're probably one of my students, you are a parent, guardian, or tutor to one of my students, or you are one of my team members. Whichever the case may be, thank you so much for watching. Please stick around and watch the entire video and provide me with some feedback at the end. That will help me out tremendously in determining if this channel or this series is something that I want to maintain moving forward. The idea behind this video is to provide you, the student, with some additional support at home with all the content and the material that we discuss in class. More specifically, we will be reviewing 7th and 8th grade math as well as Algebra 1. Having said that, let's jump into it. 8th graders, you will recall this past week our section was estimating roots. Now before we get into it, let's quickly review what we did the week before, which was just roots. You will recall a square root is a number or the factor that you multiply times itself twice to give you the desired product. For instance, if you have 25, the square root is 5. If you have 9, the square root is 3. Notice we are looking at what we call perfect squares. That means that the root is a whole number, it is an integer. What happens though if you are looking for the square root of a number that is not a perfect square? That is what we will be doing in this section. Let's do, for example, you want the square root of 8. As we previously established, 8 is not a number that has a perfect root. It is not a perfect square. However, we know that there are numbers very close to 8 that do. For example, square root of 9 is equal to 3. 8 is less than 9. Is there another perfect square close to 8? Sure. 4 has a root of 2. So, if we were to align them, 4, 9, and our original problem in the middle, we are able to determine that the square root of 8 is somewhere between 2 and 3. We don't know what number it is exactly, but we are approximating. That is the essence of this lesson. It is what we are doing. To determine which one of these two values it is closest to, simply look at your original number and determine, is my original number closer to this number or to that one? In this case, the difference between 8 and 4 is 4. The difference between 9 and 8 is 1. Having a smaller difference, it is closer to 9. Meaning that your square root, or the square root of 8, is approximately 3. Let's do another example. Let's say I want the square root of 90. Again, for the purposes of this lesson, one thing to remember is you are estimating, therefore all of your problems are not going to have the perfect square root. What you have to do using your chart or multiplication table, find perfect squares that are very close to this one. If you're familiar with your 1 through 12s, one of them might stand out. 100, right, Square root of 100 is 10. And if we take one just below it, 9, well, 9 squared will give you 81. Just like we did with the previous section, line them up. You have square root of 81, which is less than 90, and square root of 100, which is greater than 90. Okay? And once again, if you are to evaluate, you are to simplify, we are able to determine the square root of 90 is somewhere in between 9 and 10. Again, we are not looking for an exact value, we are simply estimating. And just like we did with the previous example, find the difference between 90 and 81 by subtracting. 90 minus 81 is 9. 100 minus 90 is 10. This one is closer to the middle compared to the other example, but this is a smaller difference no less, meaning that the square root of 90 is going to be approximately 9. Let's do one final example. This time we will do a cubed root. From our previous lesson, you might recall cube roots. It is very similar to a square root, with the only difference that you are now not multiplying by 2, you are now multiplying by 3. Let's say you want the cube root of 50. These problems might be a little more challenging because when you are practicing multiplication, more often than not, you only the standard charts that we practice are usually only count with 2 factors. This one has 3. Again, if you're one of my students, I did hand you out a chart with integers 1 through 20 with all the squares and the cubes. Please feel free to ask me for another one if you have misplaced yours. So again, if you are familiar with some of your perfect cubes, you might be able to quickly identify them. Otherwise, again, please allude to your chart or feel free to Google one on your own time. One perfect cube very close to 50 is 27. The cube root of 27 is 3. 3 times 3 is 9, times 3 once more will give you 27. Will be less than 50, so let's try one number higher. If you multiply 4 times itself 3 times, 4 times 4 is 16, times 4 once more, that would give you 64. Again, line them up just as you did in the previous examples. Cube root of 27 less than cube root 50 less than cube root 64. And in the same way, we're able to estimate that the cube root of 50 is somewhere between 3 and 4. Which one is it closest to? Again, find the difference between your original problem and the perfect cubes that you found on your own. 50 minus 27 would give you 23. 64 minus 50 would give you 14. Therefore, your cube root is going to be approximately 4. All of your problems in the homework will be similar to this. Again, if you have any questions, feel free to comment below or send me an email. And hopefully this video helped you out.